So for this lecture, we will learn another technique of integration. It's called trigonometric substitution. Okay, so for this technique, I hope you have practiced your trigonometric integrals because a lot of the, well, one of the steps in completing the solution of your integrals after doing the trigonometric substitution is trigonometric integrals. Okay, so I hope you remember all the steps. I hope you practice some integrals that are similar to that or to those that we did last meeting. So just a prerequisite, well, this is the forms that we will integrate. So we have the square root of a squared minus u squared, square root of a squared plus u squared, and the square root of u squared minus a squared. Okay, so our integrals will involve these functions. Okay, some prerequisites. We recall some trigonometric identities, particularly the Pythagorean identities. So you have your sine squared plus cosine squared, that's equal to 1. Okay, or sine squared theta plus cosine squared theta, that's equal to 1. But what we're going to do is to isolate sine squared theta. And then coming from this, we can derive a formula for tangent squared theta. And that one will be equal to secant squared theta minus 1. And then again, deriving from this equation here, we can get this identity. Secant squared theta is equal to 1 plus tangent squared theta. We also need to recall this mnemonics. So SOHCAHTOA. Okay, so given a right triangle, let theta be the measure of one of the acute angles. So for example, if we have this right triangle here, okay, this will be theta. So it's the measure of one of the acute angles. Okay, then we have the following. The value of sine theta, that is equal to the opposite side over the hypotenuse. So opposite side, it's just the side opposite of your angle theta. So this is your opposite, okay? And then of course, your right triangle, the longest side there, it's your hypotenuse. So this is your hypotenuse. And then the other side here, okay, it is called the adjacent. So the value of sine theta, it's equal to the opposite side over the hypotenuse. The value of cosine theta, that's equal to the adjacent side over the hypotenuse. And the value of tangent theta, that's equal to the opposite side over the adjacent side. So SOHCAHTOA, S-O-H, that's your SO. Ka, this is your C-A-H. And then for the TOA, this is your T-O-A. So SOHCAHTOA, it's a famous mnemonics. In getting angles of right triangles or sine, cosine, or tangent of right triangles, etc. Okay? So, let's now proceed to our techniques. First, let us consider integrals of this form, square root of a squared minus u squared. So if you see something like this as an integrand or a portion of integrand, you may use this substitution. So in here, a is a constant, okay? And particularly, we assume a here to be positive, okay? We assume a to be positive. And then u, it's a function, okay? It's a function. So when you see this is the substitution that you will do. u equals a sine theta, and your theta must be inside to negative between, or your theta must be between negative pi over 2 and pi over 2 inclusive. Okay? If this is your substitution, then du will be equal to a cosine theta d theta. Okay? Furthermore, you will have this. If you square u, you will get a squared sine squared theta. And if you try to find a squared minus u squared, you will have this. So a squared minus u squared, this is a squared minus a squared sine theta or sine squared theta. And you can factor out a squared. So you will have a squared times 1 minus sine squared theta. Okay? But from here, you will get a squared cosine squared theta. Okay? So how did we get this? Well, it's still coming from this guy here. Sine squared theta, it's equal to 1 minus cosine squared theta. Or you have cosine squared theta equals 1 minus sine squared theta. So you put this guy on the other side, and then you put this to this right-hand side, and you will have this identity. Okay? So this means that if we get the square root of this, okay, if you get the square root of this, you will only have, so square root of a squared minus u squared, you will only get a cosine theta. And take note, theta must be between negative pi over 2 to pi over 2. Because on this interval, the value of cosine theta is positive or 0 if you are at the endpoints, or if theta is at the endpoints. Okay? So this means we don't have to put the absolute value. Okay? So from square root of a squared minus u squared, when you do your substitution like this, you'll just get a cosine theta after doing this square root of a squared minus u squared. Okay? And then you will be able to convert the integrals into trigonometric integrals. Okay? Let's practice this. Let us integrate square root of 1 minus x squared dx. If you recall, at the first lecture or second lecture, we were able to integrate a similar problem, okay, using circles, okay, using semicircles or quarter circles if we have definite integrals, if we put limits of integration, okay. But what if we don't have that uh, or those limits of integration? So how do we integrate this? So we use the substitution we just learned. So in here, you let x be equal to 1 sine theta, or just simply sine theta. Your a here, it's just 1. Your u here, it's just x. Okay? So let's just write x equals sine theta. Okay? Then du, then, or dx, this is equal to cosine theta. And furthermore, you have square root of 1 minus x squared. This is square root of 1 minus sine squared theta. And this is simply cosine theta. And therefore, this guy here, okay, will become integral of. So you have the square root of 1 minus x squared. That's your cosine theta here. And then the dx, it's cosine theta d theta. I forgot the d theta there. So you have here cosine squared theta d theta. Okay? And then we just have cosine squared theta as an integrand here. We can apply an identity, or we can use an identity. This is, so this cosine squared theta, it's equal to 1 plus cosine 2 theta divided by 2, and then you have the theta. Okay? So if we integrate this, we will have 1 half theta. Take note, the variable of integration here, it's theta. So don't forget that. Plus, you have the 1 half, and then you integrate your cosine 2 theta. That's sine 2 theta over 2 plus the arbitrary constant c. Okay? But your original variable is x. So we have to convert this theta and sine theta, okay, to something in terms of x. So how do we do that? Let us rewrite this guy here. Okay? You have 1 half theta plus 1 half sine 2 theta. That's equal to 2 cosine theta sine theta. And then you have the over 2 there, and then the plus c. And rewriting this further, we will have, let's write this as theta over 2 plus cosine theta sine theta over 2, and then plus c. So now, how do we bring back the x? Okay? So there was a question, is this the half angle formula? This guy here, it's the half angle formula. Okay? This is related to half angle formula. This guy here, this is related to double the angle formula. Okay? Next question. Yes, Riyad?
Uh, yeah, I just don't understand. Uh, where does 2 cosine came from?
This guy here, it's, again, it's the double the angle formula. So it's an identity. You have cosine, or you have sine 2x. This is equal to 2 sine x cosine x. That's an identity, a
Okay.
trigonometric identity. So we
Okay.
just used that. Okay?
Yep. Thanks.
You're welcome. Now, again, we want to bring back the x. You see this, you have sine theta in here, and that's just x. Our problem is, what about cosine theta, and what about this this theta here? Cosine theta, it's already in here actually. Cosine theta, that's square root of 1 minus x squared. So we can just replace the cosine theta with this. So the last thing now is, what about this theta? Well, we just use inverse trigonometric functions. Okay? From here, okay? From here, we will have theta equals sine inverse of x, which means this guy here will just have sine inverse of x over 2 plus sine theta. that's just x. Cosine theta, that's square root of 1 minus x squared. And then you have your over 2. And then the plus c. So this is the final answer. This is the integral of this guy here. Okay? Any questions? Your hands is raised. Is that from before?
Yeah, sorry.
Let's have this example. We want to evaluate integral of x squared over 4 minus x squared dx. So looking at this part here, you see it is of this form. Okay? Your a squared, that's equal to 4. Okay? That's equal to 4. So your a, that's 2. Therefore, you can let x, this is equal to 2 sine theta. And then dx, that's equal to 2 cosine theta d theta. And then we want to change this x squared into in terms of theta. So from here, you will have x squared. This is equal to 2, or this is equal to 4 sine squared theta. And then this guy here, this square root of 4 minus x squared, you will have square root of 4 minus x squared. This is square root of 4 minus 4 sine squared theta. And this is just 2 cosine theta. Thus, we now have the following. X squared, that's 4 sine squared theta. And then we have the dx, okay? Dx, so times 2 cosine theta d theta. And then the denominator here, it's 2 cosine theta. So over 2 cosine theta. And therefore, if we simplify this, we'll have the integral of 4 sine squared theta d theta. So 2 cosine theta will cancel this guy here. And again, we just have a power of sine. Actually, we have sine squared. So we'll use again the half angle formula or half the real number formula. So if we do that, we will have 4 times 1 minus cosine 2 theta divided by 2 d theta. And then let's just again integrate this. So 4 over 2, that's just 2. And then quantity. Integral of 1 d theta, that's theta. Minus integral of cosine 2 theta, that's again sine 2 theta divided by 2. And then we have the plus c. And then again, let's just convert this sine 2 theta. Let's use the double D angle formula. So we will have 2 times theta minus sine theta times cosine theta. Then you have the plus c. Okay? Now, we bring back our x. So notice here, okay? Notice that from this, we will have sine theta. This is equal to x over 2. For the cosine theta, you look at this. Square root of 4 minus x squared, it's equal to 2 cosine theta. So you can solve for cosine theta immediately. Okay? You will have cosine theta. This is equal to square root of 4 minus x squared over 2. And then for the tangent, or for the theta in here, we use this. Okay? Our theta will be sine inverse of x over 2. And therefore, this guy here, okay, this guy here will just be 2 times sine inverse of x over 2 minus, for sine theta, that's x over 2. And then for cosine theta, that's square root of 4 minus x squared over 2. And then we have d plus c. Okay? Are we good? Now, so far we haven't used SOHCAHTOA. Okay? It's because you just have these angles or these trigonometric functions, sine and cosine, and they can be derived easily. But there will be a time where you will have to find tangent theta, cosecant theta, cotangent theta, secant theta. Okay? And when that time comes, you will use your SOHCAHTOA, the right triangles that we illustrated in here. Okay? So in our examples later, we will see that. Let's do this next example. So we want to evaluate dx over x squared, square root of 9 minus 4x squared. So in here, we have a that's equal to 3. For this guy, before we just have x squared. Now we have 4x squared. That is our u. U is 2x, or u squared, that's equal to 4x squared. So instead of just using x in your substitution, we will use 2x. This 2x, this is the one equal to 3 sine theta. Okay? Follow? Because again, this guy here, this is actually your u squared. So here, where u, that's equal to 2x. And in our derivation earlier, we have u equals a sine theta. But u here, it's 2x. So we have 2x equals a sine theta. Okay? Now, from here, we have 2dx. It's equal to 3 cosine theta d theta. Okay? And also from here, we need x squared only. Okay, you see this? We only need x squared. So we write x equals 3 sine theta over 2. So x squared, this is equal to 9 sine squared theta over 4. Okay? Furthermore, you have square root of 9 minus 4x squared. Okay? This is equal to square root of 9 minus 9 sine squared theta. How come? You have 4x squared here. You look at this. This guy here, if you put it beside x squared, you have 4x squared. And that's your 9 sine squared theta. So if you continue simplifying this, you'll just get 3 cosine theta. Therefore, what will we get in here? We have the integral and then the dx. We have 2 dx in here. So dx, that will become 3 halves cosine theta d theta. Then all over x squared from here. So we will have 9 over 4 sine squared theta. And then we have the square root of 9 minus 4x squared here. It's just 3 cosine theta. So times 3 cosine theta. And if we simplify this, of course, cosine theta will cancel this cosine theta here. Okay? And then what else? The constants. The 3 here will cancel the 3 here. The 2 here will cancel the 2 here. And you'll be left with 2. So try to work on that constant. You should get 2 over 9. Integral of 1 over sine squared theta. And then you have the d theta. But 1 over sine squared theta, that's just cosecant squared theta. So you have 2 over 9 integral of cosecant squared theta d theta. And here, integral of cosecant squared theta, that's negative cotangent theta plus c. Okay? And now, how do we convert this? So we use this. Okay? This is what we know. We have the right triangle. This is your theta. From here, okay, we have sine theta. This is equal to 2x over 3. Okay? That's just 2x over 3. We divide this guy here by 3. And sine theta, that's equal to opposite over the hypotenuse. So the opposite, we have 2x. And then here is your denominator. This will be your hypotenuse. Okay? And this is just a right triangle, so you can use your Pythagorean theorem. Okay? So to get this side here, okay, to get this side here, you will have 9 minus 4x squared. Square of this minus the square of this, that's equal to the square of this. Remember your Pythagorean theorem. Okay? And then, you now have this triangle. This implies that your tangent theta, this is opposite, that's your 2x, over the adjacent, this is your adjacent, square root of 9 minus 4x squared. We need cotangent, so we just need the reciprocal for this. And therefore, this is now equal to negative 2 over 9 times square root of 9 minus 4x squared all over 2x. And then you have the plus c. So this is the final answer. Okay? Questions on this form? Square root of a squared minus u squared. Okay? Let us consider another form. So this time you have square root of a squared plus u squared. So we now have plus for this. If we have this, we use this substitution. U equals a tangent theta. And in here, your theta must be between negative pi over 2, comma pi over 2. Or must be between negative pi over 2 and pi over 2. And we do not include the endpoints. Because, of course, at pi over 2 or negative pi over 2, tangent will be undefined. So we do not include that the endpoints. So if we have this substitution, of course, you will have du. Du, that's equal to a secant squared theta d theta. Okay? And you may compute for a squared plus u squared, and you get the square root of that. This will be equal to square root of a squared plus a squared tangent squared theta. You factor out a squared. So you will have a squared times 1 plus tangent squared theta. And this 1 plus tangent squared theta, it's just your secant squared theta. So you have square root of a squared secant squared theta. And again, we take the square root. This is just a secant theta. And just like before, we don't have to put the absolute value in here because on this interval, negative pi over 2 and pi over 2, okay? So between negative pi over 2 and pi over 2, the value of secant theta is positive. So we don't have to put the absolute value thing in here. Okay? Let's try this using this example. So we want to integrate square root of 4 plus x squared dx. So in here, we have a equals 2. So we can let u, or in here, we can let x equals 2 tangent theta. Dx will be 2 secant squared theta d theta. Okay? And if we calculate square root of 4 plus x squared, so this is equal to square root of 4 plus 4 tangent squared theta, we will get 2 secant theta. So we now substitute. In here, we will have the integral of, for this guy, we have 2 secant theta. And then the dx, it will be 2 secant squared theta d theta. So 2 secant squared theta d theta. Or this is just for integral of secant cube theta d theta. And now we have an integral with powers of secant. And we don't see any tangent in here. So we'll just apply um, the reduction formula for secant. And we do that because the power is odd. If the power was even, then it's totally fine. Now we will have the easier method. But this power here, it's odd. So we have to use the reduction formula. If you don't remember, let's write that. Secant to the n x, if you integrate this dx, this is equal to tangent x secant raised to n minus 2x over n minus 1 plus n minus 2 over n minus 1 integral of secant to the n minus 2x dx. Okay? So we use this. We will have 4. Then we integrate secant cube theta d theta. We'll have tangent theta secant theta over 2 plus 1 half integral of secant theta d theta. And then we continue with the integration here. So this is equal to 4. Let us distribute this 4 so that we will only get 2 tangent theta secant theta plus 2, and we integrate secant theta. This is just ln absolute value of secant theta plus tangent theta. And then we have d plus c. Yes, question? Riyad.
Yes, sir. Isn't sec supposed to be sec squared?
Where? Secant theta. This is
20.
secant cube.
Yeah,
And
I
you
know.
have n minus 2. So 3 minus 2, that's just
Oh,
1.
minus 2.
Yes,
Okay,
this
thanks.
is 3 minus 2. This is also 3 minus 2. So if it is
Thanks.
n minus 2. Okay? Other questions? Now, we have tangent theta, secant theta. In here, we also have secant theta and tangent theta. Tangent theta, we can get it from here. Secant theta, we can also get it from here. So we don't have to use the right triangle. We're lucky because the trigonometric functions that we need in here were already calculated implicitly in here. So we will have, so from here, we'll get tangent theta. This is equal to x over 2. And then from this guy here, let's just write it here, secant theta, this is equal to square root of 4 minus or 4 plus x squared all over 2. And therefore, this guy here, it's equal to 2 times x over 2 times square root of 4 plus x squared over 2 plus 2 ln absolute value square root of 4 plus x squared over 2 plus x over 2, and then plus the arbitrary constant c. So this is the final answer. Okay. Any questions? So there was a question, how was integral of secant theta equals ln? We derived that. We derived that formula. Okay. So the question was, how did we get from this up to this? We derived the formula. So you can go back to the topic, substitution rule. Okay. And you will find a formula for that integral. Other questions? Next example here, we have square root of 16 plus 9x squared over x squared. So in here, we have a squared that's equal to 16. So your a, it's just 4. And then the u squared is equal to 9x squared. So u is just 3x. And we have a plus in between here. So the substitution will be the tangent substitution. So 3x, that's equal to 4 tangent theta. Then we have 3dx. This is 4 secant squared theta d theta. And then what else? We need x squared. Okay. So from here, we can square both sides. We will have 9x squared, that's 16 tangent squared theta. Or we have x squared equals 16 tangent squared theta over 9. Therefore, well, if we compute for square root of 16 plus 9x squared, this is equal to square root of 16 plus 16 tangent squared theta, or we just have 4 secant theta. So this guy here can be transformed into the integral. So we will have square root of 16 plus 9x squared. That's equal to 4 secant theta. We have the x squared. So we have 16 tangent squared theta over 9. And then we have 4 secant. We have the dx. The dx is 4/3 secant squared theta d theta. So times 4 over 3 secant squared theta d theta. So if we simplify this, we will get, we have 4 times 4, that's 16. So this guy here will cancel this. Okay. And then we cancel this and this. We'll be left with 3. So we'll have 3. I'll put that 3 outside. So we'll have 3 integral of secant cube theta over tangent squared theta d theta. Okay. And then from here, what we're going to do, so notice you have odd power for secant and even power for tangent. So we cannot use any of the first two methods. So what we're going to do first is to simplify this. Maybe we can work on that. Okay? Let's see. We have 3 integral. Tangent squared theta in the denominator, okay? It will become cotangent squared theta in the numerator. But in any case, secant squared or secant cube theta, that's 1 over cosine cube theta. And then for the tangent squared theta on the denominator, you can write it as cosine squared theta over sine squared theta. Okay? And what will we get? So from here, we'll have 3 integral of, so cosine squared, in here we'll cancel the cosine squared in the cosine cube. So we will have 1 over cosine theta. And then we still have this sine squared in here. So times 1 over sine squared theta. Okay? And then from here, what can we do? Of course, there should be a d theta in here and also a d theta in here. So we rewrite this as 3 integral of 1 over cosine theta, that's secant theta. And then 1 over sine squared theta, that's cosecant squared d theta. And then we can do integration by parts. So let's have that trial. Say we let u be equal to secant theta, and then dv. This is equal to cosecant squared theta d theta. Du will have secant theta tangent theta d theta. Whereas v, this is equal to negative cotangent theta. Okay? So from here, what will happen? We have equals. So this is the substitution that we will use. Let me move this. So before I move that, I'll resize and then move it here. Okay. So from here we have 3 quantity. UV. So you will have negative secant theta cotangent theta minus integral of V du. We have negative cotangent theta and then secant theta tangent theta d theta. But notice, cotangent theta times tangent theta, that's just equal to 1. So we'll just have here 3. So we'll just have 3 negative secant theta cotangent theta plus integral of secant theta d theta. Again, it's because cotangent here will cancel the tangent there. And now, we can integrate this easily. Okay? So, we have 3 times negative secant theta cotangent theta plus integral of secant theta. That's again ln, absolute value of secant theta plus tangent theta. And then we have the plus c. Okay? And then now we need to convert this to something in terms of x. Okay? So for that, let us continue on this page. So we have here, okay? So we have here equals, and then we have this equal sign. And let us recall, we got 3x. This is equal to 4 tangent theta. Cotangent theta, we can easily get it. Because you got here, tangent theta equals 3x over 4. The reciprocal will just be the cotangent. So cotangent theta, it's 4 over 3x. And then from this slide, we can easily get secant theta. Secant theta, it's just this divided by 4. So from there, we have secant theta, it's equal to square root of 16 plus 9x squared over 4. So we're done there. So this is equal to negative 3. Secant theta, it's square root of 16 minus, or 16 plus 9x squared over 4. Then cotangent theta, it's 4 over 3x. You can even simplify this. This is just cosecant theta if you multiply them out. And then plus 3 ln absolute value square root of 16 plus 9x squared over 4 plus 3x over 4, and then plus the arbitrary constant c. So this is the final answer. Okay? Questions? Now, let us consider this last form. Square root of u squared minus a squared. So we have a minus again, but we interchange the u and the a. Okay? So for this, we let u be equal to a secant theta. And this time, our theta will be between, or it will be in this interval, 0 to pi over 2, including 0 but not pi over 2, or pi to 3 pi over 2. including pi, but not 3 pi over 2. Okay? So if you look at this in your circle or on your circle, this is first quadrant, this is third quadrant. And we need that. We need the first quadrant and the third quadrant. Why? Well, let's start with the du first. Du, this is equal to a secant theta tangent theta d theta. Now, we have u squared. This is equal to a squared secant squared theta. And if we look at square root of u squared minus a squared, this will be equal to square root of a squared secant squared theta minus a squared. We factor out a squared, and we will have square root of a squared times secant squared theta minus 1. And then, if you simplify this, you will just have a tangent theta. So, for this, we don't have to put absolute values because the value of tangent theta in this interval or in this interval, it's always positive. Okay? So again, if you see this form, square root of u squared minus a squared, you use this substitution. Okay? Let us consider this example. We want to evaluate dx over square root of x squared minus 9. And I have double dx there, so let me remove that part. So we let x, our a here, that's equal to 3. Okay? Then we let our x, this will be 3 secant theta. And then, of course, dx will be 3 secant theta tangent theta d theta. And then if we calculate x squared, this is just 9 secant squared theta. And therefore, square root of x squared minus 9, this is just square root of 9 secant squared theta minus 9. And if you simplify this, you'll just get 3 tangent theta. Which means this guy here, you can now write it as a integral of, so dx, it's 3 secant theta tangent theta d theta. And then the denominator, it's just 3 tangent theta. So as you can see, 3 will cancel the 3 here, tangent will also be cancelled. So you'll just have integral of secant theta d theta. So the answer will be straightforward. Integral is just ln absolute value of secant theta plus tangent theta, and then you have the plus c. And then secant theta in here can be calculated using this. Tangent theta can be calculated using this. Which means we will just have ln absolute value of x over 3 coming from here. Let me write that for completion. So coming from here, secant theta, that's x over 3. And then Coming from here, we'll have tangent theta. That's equal to square root of x squared minus 9 over 3. Therefore, we have this as our final answer. So this is our final answer. That's the integral of dx over x squared minus 9, or dx over square root of x squared minus 9. Okay? Another example here, integral of square root of x squared minus 4 over x. So again, our a here, that's equal to 2. We let x to be 2 secant theta dx. This is equal to 2 secant theta d, or tangent theta d theta. And then we have square root of x squared minus 4. That's equal to square root of 4 secant squared theta minus 4. And this is just 2 tangent theta. Therefore, this guy here, this is equal to integral. We have the square root of x squared minus 4. So that's just 2 tangent theta. We have over x. X is 2 secant theta. So you have here denominator as 2 secant theta. And then the dx. In here you have 2 secant theta tangent theta d theta. Which means we can cancel this 2 secant theta and this guy here. And this simplifies into the integral of 2. Let me put it outside the integral. Tangent squared theta d theta. And now you see, you have a power of tangent. And the power of tangent, it's even. So we can use the simpler method. Yes, we use the identity. So we will have the integral of secant squared theta minus 1 d theta. So if you have an even power for tangent, you do something like this. Okay? So if we integrate this, we just have 2. The integral of secant squared theta, that's tangent theta. Then minus 2, integral of d theta, that's just theta. And then we have the plus c. And then from here, since we need a theta, we can calculate theta from here. So we have secant theta, that's equal to x over 2. Or your theta, this is equal to secant inverse x over 2. Tangent theta can be calculated using this guy. In fact, you have 2 tangent theta and you have these 2 tangent theta in here. So we'll just have square root of x squared minus 4, then minus 2 secant inverse of x over 2. And then we have the plus c. Okay? questions? Okay, so one last example that I want to work for this session. We have this integral dx over e to the 2x plus 16 raised to 3 halves. So in here, we look at this e to the 2x. You can write it as e to the x quantity squared. So this will be your u. Okay? So you have your u squared plus 16. So we have a plus in here. If we go back to the methods, this is the plus. We use tangent substitution. Okay? So for this, our a, that's equal to 4. And then our u, that's e to the x. And we use tangent substitution, so we have e to the x equals 4 tangent theta. And if we get the derivatives, we have e to the x dx. This is 4 secant squared theta d theta. But we only need dx, and we have e to the x dx in here. So we can write dx as 4 secant squared theta d theta divided by e to the x, but e to the x, it's 4 tangent theta. So if we simplify this, we'll just have secant squared theta over tangent theta d theta. So in here, we will have what? Furthermore, we have e to the 2x plus 16. So we have e to the 2x plus 16. That's equal to 16 tangent squared theta plus 16. And this is just 16 secant squared theta. So now, let us do all the substitution in here. I will have the integral. For the dx, I will have secant squared theta over tangent theta. And I'll put the d theta somewhere here. And then for e to the 2x plus 16, that's on the denominator. Okay, so we will have 1 over 16 secant squared theta. But this is raised to 3 halves. So this guy here, this is raised to 3 halves. So if we simplify this, we will have the integral. You have secant squared in the numerator. On the denominator, you have tangent theta. Secant squared, you raise it to 3 halves. That's secant cube. So you will have secant cube in here. And of course, 16 raised to 3 halves, that's 4 cube. That's 64. And then you have your d theta. So if we simplify this is 1 over 64 integral. 1 over tangent theta secant theta d theta. And then what will happen? We'll just have 1 over 64 integral of, let's write this as cotangent theta cosine theta d theta. And what else? Cotangent theta, that's cosine theta over sine theta. And then multiply this to cosine theta, d theta. Or we have here 1 over 64 integral of cosine squared theta over sine theta d theta. But cosine squared theta, that's just 1 minus sine squared theta. So cosine squared theta, that's 1 minus sine squared theta. And then you have here over sine theta d theta. And then you'll just separate them. You have 1 over 64 integral of 1 over sine theta minus sine theta d theta. Or simply, you have 1 over 64 integral of cosecant theta minus sine theta d theta. Okay? And then let us continue on this side here. So we'll have 1 over 64 quantity. Integral of cosecant theta, that's ln absolute value, cosecant theta minus cotangent theta. Then minus the integral of sine theta. So you have negative cosine theta. And then we have the negative in here. So we'll get plus cosine theta. Then we close that. And then we have the plus c. And then from here, you have e to the x equals 4 tangent theta. We need cotangent theta. That's easy to find. We also need cosecant theta and cosine theta. Okay? So if we do that, let me just put the right triangle in here. This is our theta. From this guy here, okay, from this guy, we have tangent theta equals e to the x over 4. And tangent theta, that's for the TOA. So opposite will be e to the x, adjacent will be 4, and the hypotenuse will be e to the 2x plus 16, and you take the square root of that. And then from here, what do we have? Well, cosine theta, that's 4 over square root of e to the 2x plus 16. Okay, I hope you can still read this, but this is square root of e to the 2x plus 16. That's adjacent over the hypotenuse. And of course, for sine theta, this is e to the x divided by square root of e to the 2x plus 16. For cosecant theta, it's just the reciprocal of this. Therefore, we will have 1 over 64 quantity ln absolute value. Cosecant theta, it's square root of e to the 2x plus 16. So you get the square root of this divided by e to the x. And then for the cotangent, it's just the reciprocal of this. So minus 4 over e to the x. Then plus, for the cosine, you have 4 over square root e to the 2x plus 16. And then you have to close this. And then you have the arbitrary constant c. So this is the final answer.